thank you everyone for joining our webinar this morning. Looking to focus on what's going online with Varnish this year. Firstly, just a quick welcome and a short introduction to our speakers for the day. I'm Fraser, of course. I'll be your host for the webinar, but we have a presentation initially from Michael Kennedy of RTE, and then Tace Barron, our technical evangelist here at Varnish Software. They'll both be speaking, and there'll be an opportunity for a Q&A at the end. And if there are any questions that arise throughout the course of the presentations, please feel free to drop them in the chat box in the webinar portal, and we can answer those at the end. So firstly, just a brief agenda for today, and we're starting slightly late, but first off, we'll have Michael Kennedy from RTE speaking about their implementation of Varnish Enterprise and the reasons for doing so. And then we'll be hearing from Tace Barron on some of our additional features and the things that we've been working on, such as the Encore TLS and Memory Governor, that we're really excited to be sharing with you before we finalize with the Q&A session, and then sort of any closing remarks. So firstly, just for all of the Varnish customers that are on the call, just a quick piece of housekeeping. If there are any things that you see throughout the conversation today that you would like to discuss, of course, feel free to get in touch with either myself directly or with the support in the classic way. And all the documentation that we're speaking about, all the features rather that we're speaking about, should be documented either on the official documentation website or on the blog. For all of those who are not Varnish customers or who may not be quite so familiar with Varnish as a business, this is just a brief overview of who we are and what we do. We've now been going for almost, well, just over 10 years, and we've grown fairly rapidly, and towards the end of those 10 years, we're now fairly globally spread out. The most exciting announcement of which you may have seen online is the recent launch of our office in Japan. But generally, for Varnish Cache as an entity, we're used by almost 16% of the world's top websites. And Varnish Software and Varnish Enterprise adds on to Varnish Cache and ensures that we can help businesses to implement these solutions at scale. So currently we have 3 core solutions, the first of which is kind of the classic use case, Varnish Web and API Acceleration, which acts as almost an origin protection layer in front of backend services. And similarly, we offer this solution for streaming, and also we allow businesses to push Varnish nodes out into the edge of the network to actually build an owned CDN. So these are some of the customers that we offer these solutions to worldwide. And we have a huge array of different customers and different use cases as a result of the versatility of Varnish Software. And one interesting thing is that we estimate that we are delivering content currently to around 700 million active subscribers on behalf of these businesses every month. And so, yeah, the scale is really there with what Varnish can deliver from our solutions. So firstly, I would just like to now introduce Michael Kennedy, who will be speaking to us today about how and why Varnish has been implemented at RTE. And yeah, I'll take this moment to hand over to you, Michael.
Thanks, Fraser. And so good morning, everybody. My name is Michael Kennedy. I'm the Technology Infrastructure Manager in RTE. RTE is a public service broadcaster based in Ireland. We're a bit like the Irish equivalent of the BBC. We run 4 television stations, about 10 radio stations, orchestras, and a large online presence. And I'll give you a brief history of our internet activities. So RTE first went online in like 25 years ago in 1996. This was what you would expect of a website in 1996. But about 3 years later, we started to do live and on-demand video. Initially, this was just clips of the news, really. So the 1 o'clock news, the 6 and the 9 would have been streamed live in the typical postage stamp sized video of the era. You could just about make out that a human was a human, but maybe not much else. I joined RTE in 2008, just in time for the Olympics, and also for the launch of our catch-up service, the RTE Player. So initially, the RTE Player was an RTMP-based solution using Flash, which at the time was pretty much the only option for large-scale streaming. And from a network perspective, we had been running our own CDN at that time, but in my work history, we upgraded our network to a 10 gig capable network in about 2010. And in the last couple of years, we've upgraded our CDN capacity to a 100 gig capable platform. So we, over that period of time, our traffic growth at peak off our own CDN has grown significantly. As all of these graphs that you'll ever see, it's up and to the right, starting from a heady base of about 10 megasecond in the early days to something around the region of 400 gigs per second off our own CDN at peak in the last few months during various COVID-related events. So what does our CDN look like? Well, it's pretty much the same as any CDN that you would expect. We have a pair of 100 gig capable boxes out at the edge of our network. Behind that, we have just commodity off-the-shelf switches and Varnish servers. The connectivity that we get is from all of the places that we're interested in getting to. So through IXPs in Dublin it's the INEX IXP, we connect to most of the eyeballs that we're interested in reaching. As any public service broadcaster, most of our content is of interest to people in Ireland, and it's Irish eyeballs that we're predominantly interested in reaching. So INEX gives us access to about 98% of the eyeballs on the island. With some of the larger ISPs, we have direct peering arrangements, and this is where we directly plug our edge routers into their edge routers to reach those to reach the customers on their networks. And then for transit, we go to commodity IP transit providers like NTT and GTT and so on. The way the environment is built, it's fully redundant, so every piece of equipment is backed up by at least another piece of equipment, so 2 edge routers connected to all of the same places. So in the event of any failure on one side, the remainder of the environment is available seamlessly to deliver all of the traffic that we're interested in delivering. So what did we build it from? And this is of interest to those of you of a technical beat. The routers that we use at the moment are Arista 7280s. And really, these are just a switch. There's very little to differentiate them, and a lot of environments would use these just as a switch. The magic in the particular platform we use is that they're capable of taking a full internet routing table, which maybe the switch you might have at home wouldn't quite be capable of. So we receive something in the region of 2.5 million routes from all of our different peering partners. So we have full reachability to all aspects of the internet from that platform. There are 100 gig capable box, which can break out to 10 gig where you have slightly smaller requirements. Most of our connectivity at the moment would be at 100 gig. Behind that, again, off-the-shelf switches. We connect these into our core layer 3 network at 100 gigs, and all of the servers that attach to that environment are 25 gig capable servers. From a server perspective, we MLAG, so we connect each server to at least 2 switches, and we bond all the ports into one virtual entity. It means that if we want to do maintenance, we can seamlessly take one of those switches out of production and all of the servers behind don't really notice anything's happened. So we retain full connectivity, which makes maintenance and failures much easier to deal with. And then the servers that we have connected to that, they're just commodity off-the-shelf servers. We don't really differentiate very much between the live and the on-demand, except to say that the on-demand servers have a very large quantity of high-speed NVMe storage, which Varnish uses as an MSE cache. All of the servers are connected by 25 gig. At the moment, they're all connected by a bonded quad of 4 by 25 gig network interfaces. The one thing we haven't mentioned yet is load balancers, and our usage of load balancers in our CDN has changed significantly over the years. So at the moment, we operate what would be called a hybrid CDN. So while we operate our own CDN predominantly to deliver to users in Ireland, that would be the vast majority of our users, we also use a number of commercial CDNs. The commercial CDNs are used predominantly for two things. One is to reach people that we don't have connectivity to. So while I might have some users in Australia, it doesn't make sense for me to build out my CDN to reach those users. So in that scenario, we would use a commercial CDN. And also for the mega scale events, so the events where the entire country wants to watch it online. We're talking big sports events during the working day where people aren't at home watching their televisions. So we use off-the-shelf CDNs for those. And the way that we decide what CDN to use at any moment in time, be it our own or one of the commercial providers, is through a DNS-based decision engine. We feed data into that decision engine from our players, but also we put in some static rules. So the static rules would be things like, I know I don't have good connectivity to a particular CDN from my own CDN, or to a particular ISP from my own CDN. So in those scenarios, I would never want to use my own CDN. One of the issues that we face is that traffic is a thundering herd at the start of a sporting event, and you really don't have that much time to discover that you've made a poor decision. So traffic today is running at a trickle, but kickoff is at 3 p.m. and at 3 p.m. X tens of thousands of people decide to join at the same time. So we have static rules that just make sure that the DNS decision engine doesn't have to play catch up and decide that a particular CDN or a particular path is over capacity. We feed data into the decision engine from the client. So when the CDN or when the decision engine needs to decide which of 3 or 4 different CDNs is the best choice, it's making that decision based on the playback experience of our actual users. And that decision engine builds up data over time to discover which is an appropriate CDN at a particular point in time, and to deal with failures or underlying network conditions that change. When we decided to go with a DNS decision engine, it was relatively simple for us to decide not to use hardware-based load balancers anymore for our own CDN. From a cloud-based DNS load balancer, we're able to get the exact same rules, the exact same failover capability, without the hassle of having to run any load balancers. So in the last 2 years, we've effectively gotten rid of all of our hardware-based load balancers that we've been using for the last 20-something years. So what are the things that, why did we decide to build our own CDN? Now, we've been running our own CDN for as long as I've been in RTE. And every couple of years, we reevaluate that strategy of running our own CDN and to decide, is it still the appropriate thing for us to do? We're a broadcaster, we're not a CDN company, so why would we do it? And there's 4 main reasons that we run our own CDN. And we'll talk about those in a little bit more detail. So the primary one for us is cost. If it was substantially more cost effective to dump all of our traffic to a commercial CDN, we would do that. But that's not the case. It is substantially cheaper for us to run our own environment. You can see some of the numbers here that are straight off public internet sites. network connectivity is actually relatively cheap. You can get flat rate 10 gig transit for less than $1,000 a month. And if you're in a position where you can get private interconnect with an ISP, that's effectively the cost of a patch lead. So purely from a network connectivity perspective, there's a massive saving to be had in delivering the content over a network that you control. When we run the numbers, the break-even point effectively for us, at least, is under 5 gigasecond of sustained traffic over our CDN for it to be cost neutral. And even at 4 o'clock in the morning, we deliver more content than that. So it is a really simple cost-based decision. In our business case, we still have to factor in all the other costs of running the CDN, so the hardware capital costs, power charges and data centers and so on. But even with the cheapest possible CDN you can get your hands on, it's at even moderate scale, it's going to be more cost effective to build and operate your own CDN to reach your important users. And for us, it's becoming a critical element of our business. So it's something that we want an awful lot of control over. So it's not just a cost-based decision. Performance is a key one. So if you're relying on commercial CDN providers to deliver content to your critical users, you hand over an awful lot of control. I did an example here on the latency between my home IP address and both my own CDN, and we get a latency of about 16.5 milliseconds. The latency to Cloudflare from my home address is 3 times that to Cloudflare. Cloudflare is one of the biggest CDN providers in the world. They're one of the best connected networks in the world, and they still don't have as much control over the latency to their eyeballs as I do by running my own CDN. When you're using a commercial CDN, you also lose a massive amount of visibility and control. So a commercial CDN may decide on any given day that it's better to deliver your European customers from a POP in Bangalore. That's a decision that's effectively outside of your control. By running your own network, you have visibility of all of those elements, and you can control them to a significant degree. There are dozens, if not hundreds, of IXPs around the world. They're predominantly operated on a cost-neutral basis, so they're not profit-making entities, and they will get you access to the eyeballs that you're interested in reaching to a massive degree. So the Dublin Internet, or the Irish Internet Exchange, INEX, reaches over 98% of the users on the island of Ireland. That's where my users are, and that's a really cost-effective way and a high-performance way of getting to those users. The traffic doesn't leave the island; it goes straight from my network to the eyeball network without traversing halfway across Europe. There's other performance benefits that you get from running your own CDN. So one of the critical ones for us is that we can massively control how long the assets remain in our CDN's cache. So we do that based on, we know when a particular asset is useful until, and we cache it within our CDN up until the point where it's no longer valid. And we can guarantee that it will stay in the CDN's cache until that point in time. When you're using a commercial CDN, you effectively have very little control over that. The CDN may decide to shift traffic from one of their POPs to another. The secondary POP is completely cold, and all of that content has to be repulled from your origin. So when we run our own CDN, we can effectively guarantee that the content is going to be hot in the network before any user gets to it. We use a couple of Varnish features to ensure the content is hot. In the on-demand environment, we use the Varnish broadcaster to replicate content between the caches. So what this is, 2 real benefits to us. One, we can guarantee that the content is sitting on all the boxes that a user might make a request to, but it also significantly reduces the load on our origin servers. Really, we're talking here about reducing disk I/O. Every time you have to read a file from disk, there is a cost to it, a significant cost in scaling your storage to meet that demand. By using Broadcaster, we can populate 2 or 4 or 6 servers with a single request, and that reduces the load on other elements of our environment. We also use the Varnish prefetch feature to ensure that the next asset that a user is likely to request is already sitting in the cache. So when a user requests the very first fragment of a video, Varnish will make a request to the origin for the second fragment before the user is even interested in getting it. The third reason that we run our own CDN is to manage the scale. So the graph you see in front of you is effectively a typical day for us. It follows the same pattern every day, like a metronome. Nice big peak in the evening. You see little peaks for the 6 o'clock news in the evening, the 9 o'clock news in the evening, but it's the same every day. But by running our own CDN, we're able to deal with things like this. So this is the very next day. The Irish Prime Minister, Taoiseach, made a speech about what our COVID lockdown was going to look like. And half the country sitting at work decided they're going to watch that speech online. By running our own CDN, we're able to scale adequately to meet that kind of demand. Our experience is that not all commercial CDNs have the scale to deal with that kind of increase in traffic, where you're going from a steady state of whatever it happens to be, 10 or 20 gigabits a second to 200, 300, 400 gigabits a second. There isn't a reasonable business case for them to build out massive pops that get used for occasional events like that. And we can't rely on that capacity being available. And there are a tremendous number of variables in the commercial CDN environment that you don't have the ability to control. So while you might say this massive CDN is a massive CDN, they surely can deal with all of my traffic. For your particular business, that's something that you probably need some guarantees around. And by building our own CDN, we can guarantee adequate scale to deal with those events. And we can plan in advance to deal with expected load during Olympics and World Cups, whenever they may happen again. Some of the things that we've seen in the last couple of months, which have been a very strange time. So our on-demand streaming is up about 70% year on year. The uplift to us in the operating costs of our CDN have effectively been zero. So we've been able to build out additional capacity on our CDN platform to deal with that growth in traffic for effectively a few €100 in optical transceivers. So when the demand came in the first couple of weeks of March, we were very quickly able to build out and say, well, we know that there's going to be an uplift in capacity. We know there's going to be speeches that everybody's interested in, and we were able to very, very quickly deal with those. In some cases, we were able to build out capacity with particular ISPs, and they knew what was going to happen as well, and we were able to collaborate on getting a solution that worked for us and worked for the ISPs, and effectively at close to zero cost. So while our traffic has grown significantly, and it has grown significantly for all video providers, the increase in cost to us hasn't been significant. If we were paying a commercial CDN, the increase in cost to do 70% year-on-year increase would have effectively been a 70% year-on-year increase in cost, and we don't see that. The fourth reason is for visibility. So video is critical to our business. We are a broadcast, and it's important to us that we have an understanding of everything that's going on between the camera in the studio and the user at home. By operating our own CDN, we don't see control or visibility of that element to any third party. So we can tell, we know that where the traffic, how the traffic is getting to the user. We know that we're not sharing a particular port into a particular ISP with the latest game patch release or with Microsoft's Patch Tuesday or whatever. We know what capacity is available and that it is dedicated for our use. We've had situations in the past where when using commercial CDNs, we see telemetry that tells us there's a problem. We contact the CDN, they say, no, everything's fine. And then we contact our friends in the ISP and they go, no, we can see the ports are all flatlined. They've run out of capacity. By operating our own CDN, we have full visibility of everything that's happening, and we're able to deal with it either on the fly or to make capacity plans for the future. And we can see every element of the video delivery to the user and deal with issues that may happen. A slightly intangible one is the personal relationship that you end up having with ISPs. Now, for us, ISPs are part of our critical supply chain, even though we may not have a direct relationship with those ISPs. But through the peering relationships, which are effectively contractual relationships, we're also able to build personal relationships. And that is useful at times when you need to deal with issues that may arise. We've had situations in the past where ISPs know they have a problem. They're able to ring us and say, can you move your traffic from here to here? If you're doing that with a massive CDN, they possibly don't care about your particular use case. So how do we use Varnish? There's two real ways that we use Varnish. The first is as a HTTP router and origin shield. We do this for both our website traffic and for our video traffic. So we no longer deliver the website traffic, the images and the PDFs and so on, to end users. But we do use Varnish as the origin for the CDN that we use to deliver our website. And we also then use it as a media delivery server in our own CDN. So what does the layer 7 router look like? This is bog standard stuff. We can decide based on whatever parameter, what server in our delivery environment a piece of content comes from. So static images come from a static website, our web server. More dynamic content can come from a different environment, and we can shift that around as different elements of our application stack change. So we may run WordPress in one particular area of the site. The public don't need to see that. It's all under one host name, and we can direct the traffic as we need to. And then we also use it in that scenario as a load balancer. So we would make decisions about which of a pool of servers is appropriate to deliver the content from at that point in time, deal with maintenance, deal with failures, and so on. The CDN we use for our website, they don't need to know anything about that. They treat our Varnish origin tier as their only backend. I mentioned we use it as a video delivery as well, and that's just big and dumb, massive amount of RAM or massive amount of storage, and pump the traffic straight out. And we do the same type of layer 7 routing and load balancing against our video origin servers. So if it's on-demand video, it comes from a particular pool of servers. If it's HLS or Dash, it may come from different places. If it's encrypted content, it may come from a different environment. So there's certain tricks that we can do in Varnish that mean it's a really effective way for us to deal with issues on the fly. So when we first launched the latest version of the RT player, some devices just treat the URLs really badly. So we have an example here. We discovered post-launch that one particular app was double encoding query strings. It's not possible after you've launched to go into a smart TV and replace that application. Unlike a standard website, some of those apps take a very long time to get QA'd and released onto the devices. We're able to just go into Varnish on the fly and fix a lot of those issues. There were two issues here that I've highlighted. URL encoding is one. Another one was a particular device that didn't depend on appropriate parameter in a live video playback environment. We're able to fix that on the fly and protect our backend origin servers. And that's part of the flexibility of VCL. We also do some elements of content protection in Varnish. So we use tokens to protect the assets. We use DRM as well, but as part of a multi-layered protection solution, we use tokens. Varnish is really easily able to manipulate the data calculated token and validate it. One of the problems we had post-launch was that a particular set of devices actually mangled the tokens to a degree that made them invalid. So while that device was technically allowed to watch the content, it had mishandled the token. In VCL, on the fly, we're able to go in, find the problem with the token generation and fix it. When we have done token validation in commercial CDNs, there was only one option there, to turn off token validation. You didn't have the control that you do in VCL to fix those kind of errors on the fly. So what are the things that have changed recently in our Varnish stack? Now, we've been running Varnish for probably over 10 years, running open source before we used Varnish Enterprise. Big things that have changed recently are the use of Hitch. We use the standard recipe that everybody else used previously, which is running Nginx alongside Varnish. And for that scenario, Nginx is a pretty heavyweight application to run just for terminating TLS. So we've moved that to Hitch and significantly increased the capability of the boxes to deliver content. In the last year or so, we changed to using Unix sockets. Again, a massive decrease in the resource consumption on our Varnish servers. For media delivery, we don't even listen on port 80 anymore. There's no HTTP in that environment. So using sockets in that scenario is a really effective way of using the resources in the box. And we continue to make changes to how we use Broadcaster to more efficiently manage pre-populating content onto the CDN. And there's a number of things that we're currently investigating to change in our environment. Again, this is about making the best use of the resources that we have. So memory governor is something we're currently testing, and it'll be talked about in a few minutes. But memory governor gives us the capability of managing the available resources in the box much more efficiently. We spent many years trying to maximize the amount of RAM we used without running into trouble, especially in the live environment. Memory governor gives us the ability to do that without too much manhandling. Similarly, we'll move to in-process TLS. For us, everything is TLS at the moment. So both facing towards the user and facing towards the backend, everything is TLS. By eliminating the requirement to run a separate process, we'll increase the amount of content we can deliver off a single box without any additional expenditure. And as part of our annual capacity planning, we'll be building out our capacity again as soon as we figure out when live sports are going to happen again. So that's all we have for now. I'm going to pass to Thijs, and thank you very much for the time this morning.
Thanks a lot, Michael. Just before we hand over to Thijs fully, I've seen a couple of questions come in, but please let us know or feel free to type any questions that you have for Michael in the chat box currently, and we can revisit those in the Q&A session at the end. But as for now, I'll hand over to Thijs to discuss some of the things that we've been doing at Varnish.
Hi, everyone. Welcome. Thank you for taking time out of your busy schedules to be with us. And also thank you to Michael for the great presentation. Really enjoyed it, but also hinting towards certain features I'm going to talk about. Number one being how we handle TLS, a bit of past, present, and future. But I first like to introduce myself. My name is Thijs. I am not from the UK. Doesn't sound like a UK name. I'm Belgian, and I'm the technical evangelist here at Varnish Software. Now, before I'm going to dive in deeper about TLS, tell you a quick little story about the Unix philosophy. The Unix philosophy is all about doing one thing well, focusing on your core business and leaving the rest to other services. So that means you build something that you're really good at, and all the other bells and whistles, other solutions, other tools, maybe within that same ecosystem will handle it. And when you join forces, when all these tools work together, you can solve a bigger problem. And that is exactly what we are doing at Varnish Software. We adhere to that Unix philosophy. And the one thing we do well is performance. This is our number one priority, and we don't compromise on it. Any additional feature or any addition to the code that might compromise this performance, that might jeopardize it, we put it under heavy scrutiny before we do so. And that has had an impact on the way we deal with TLS. Now, historically, for those who have been around the block a number of times and who have worked with Varnish for a long time, know that historically we did not support TLS, HTTPS connections, or SSL, or the different terms you could use for it. And we, again, did that from this core business perspective, from that Unix philosophy. Our thing is performance, and cryptography is a different domain with its own complexities and its own challenges. So for years, we didn't really support it. But currently, we live in a world where TLS is everywhere. And even Michael said it in his presentation. They hardly use plain HTTP. It's all TLS. So how can we say with a straight face that we're an industry-leading web acceleration tool and content delivery platform without supporting TLS? And this is more amplified by the Let's Encrypt project, a sort of joint venture from all major Silicon Valley companies and global players in an attempt to democratize the use of TLS. Let's Encrypt allows users to have TLS certificates for free, and it's really easy. So with that in mind, we have to fast forward to 2015, where we decided to tackle this problem, but in our own particular way, and again with the Unix philosophy in mind. Instead of building TLS directly into Varnish, we decided to build a little service, Hitch in this case, and again, thank you again, Michael, because you hinted towards it. RTE uses it. It is a dedicated, scalable TLS proxy. It is developed by us. It is developed by my colleague Doug in Oslo, and it does the job. What it basically does is it's an extra hop that you put in front of your Varnish, and its sole responsibility is terminating TLS. So it accepts HTTPS connections and sends plain HTTP to Varnish. Now, again, because cryptography is a domain of its own, we split that out and split the responsibilities. Now, from an efficiency point of view, we could say that Hitch is a TLS proxy. It does nothing more. It doesn't even understand HTTP. Like a lot of the tools that people out there use serve different purposes. In this case, Hitch doesn't. It is extremely lightweight and extremely powerful because it's built for the job. It does this one thing well. Again, Unix philosophy in mind. And that results in capabilities of transferring over 100 gigabits per second per server when connecting Hitch to Varnish. Now, Hitch is open source. It's not a commercial product. You can get it wherever you want. And even if you use Varnish Cache, you can get a hold of it and use it. These are the various ways of getting Hitch. You can get it off the website. You can look at our GitHub releases. You can even look at the code on GitHub. If you have a Debian or Ubuntu system, you can use the apt-get package manager and install it. And we're even working on an official Docker container. But that's if you're doing it on your own. If you have a subscription with us, if you partner with us, we'll make sure that we have a specific package management system to give that to you. So if you're on a Debian or Ubuntu system, we'll offer packages through Varnish plus add-on SSL, which is a package, and there's an equivalent for Red Hat, CentOS, and Fedora systems. Now, we will do that for you if you set up a system, if we manage your system. But I just wanted to show you that in our release schedule, we have these packages to make sure that everything is fully maintained. So you have your bug fixes, your security updates, and we also make sure that when new features arrive, you will get them. This is also the case when you're in a self-service model. We do offer Varnish Enterprise on various cloud platforms, such as Amazon Web Services, Microsoft Azure, Google Cloud, and more recently, the Oracle Cloud Infrastructure. We offer our software as pre-installed images. So when you bootstrap these images under the form of a virtual machine, you have a ready-to-go Varnish setup, including Varnish Enterprise, but also with Hitch. Now, I wanted to quickly show you how to configure Hitch. It's quite interesting, and it will help towards the buildup of this presentation. So the Hitch configuration is done in a simple conf file. In this case, this is hitch.conf, and it has a variety of settings from network port association to backend connectivity. And you can see all this cipher suites, TLS, protos. So everything regarding cryptography can be tuned as well, but out of the box, it's pretty much up to spec with the conventions. But because it's all about TLS, we do need to focus a bit on the certificates. The certificates are quite important. And you might have spotted it already. There is a directive called PEM file. Now, PEM is a certificate encoding format. And in this case, there is it's even a dummy certificate, a self-signed dummy certificate called example.com, hosted in that etc hitch certs folder. I'm going to show you what that could look like. Please don't be too scared with what you see. It might look like gibberish. This is just base 64 encoded data, it's just crypto data. But the data itself doesn't really matter too much. It's what you see in the file. It's the boundaries that matter. And I zoomed in on it, and you can see begin certificate, end certificate, and much more. So what you see in this PEM file, it's a combination of certificate information, also your certificate authority chain could be part of it, your private key, and other parameters, all jam-packed into that one file. So that is enough to bootstrap that TLS certificate. and to have a secure connection. But if you want multiple certificates, you can issue that PEM file directive multiple times, each pointing to a different file. And we will use built-in SNI, server name indicator, to actually inspect what host name you're connecting with, what is the host header, and then how do you match it to either of those certificates. That will happen automatically. If you need more flexibility and you don't want to explicitly define the different certificates, you can all drop them in a folder using PEMDIR and then filter it out using a glob parameter. So in this case, we're going to the etc hitch cert.d folder, and we're loading everything that ends with PEM. That gives you required flexibility. If you want more flexibility, you want to split it up further, you can even choose to split up the certificate location and location of the private key. So all of that is very flexible and very easy to manage. And I can already hear you sigh. I might even feel it. You can say, yes, that's all good, but yet another service to manage, yet another hop the traffic has to go through. And although that is true, the latency will be very minimal. And Michael told it as well, they like it a lot, and it reduced their latency. But if it's yet another service you have to manage in terms of complexity, well, we have something to soften the blow. And the fact is that Hitch and also Varnish, and there's plenty of other technologies in the world that support it, they all support the proxy protocol. The proxy protocol is a subset, it's an extension of the TCP package that was invented by the lovely people at HA Proxy who deliver open source load balancing. And what that does, and the way we leverage it, is to make sure that these extra nodes you had in front of Varnish, such as Hitch or other services, that they can transport the original client IP. Because to Varnish, it seems like there's only one client, and that is Hitch. But originally, a connection was made from a user. So the proxy protocol stores the original client IP and transports it end-to-end over systems that support the proxy protocol. So to Varnish will end up with this one. It will receive an X4 request header containing the IP of the original client, regardless of the number of hops. So that makes life a lot easier. And you can enable that. You can enable that in Hitch by enabling this parameter. Of course, knowing that Varnish should be enabled with proxy protocol as well. We added more bells and whistles to make this a lot more interesting. Even in VCL, VCL is our built-in programming language, our domain-specific programming language used to manipulate the behavior of the cache. Well, we even have a module called proxy, and it has a variety of methods, but I just wanted to show you that we can detect whether or not an incoming request was made over SSL. So if that was not the case, as you can see in this example, we can already go ahead and redirect users to HTTPS equivalent. And there's a host of other applications and use cases, but I just wanted to show you that we have this. Now, this is all fine and dandy, and it's very efficient, and a lot of people use it, and it's still part of our reference architecture. But we received this quote from a client. We love Hitch, but 100 gigabits per second per server is not enough for us. Now, mind you, 100 gigabits per second per server is a big number, but for those specific clients, it was not enough. So we had to look into our setup and the way we developed our technology and see where we could shave off a little bit of overhead. And at that point, in order to go past that boundary of 100 gigabits per second per server, we decided to make it in-core, in-process TLS, which basically eliminates the need to have Hitch. So Hitch is taken away, and Varnish itself can receive HTTPS requests, can do TLS. But to make it easier on users, to make it easier on ourselves as well, we decided to recycle that configuration of Hitch. So that's the reason why I showed it to you, because it matters in the buildup here. Even in core TLS, we reuse the same configuration, but a subset, of course. So if you look at this file, it might look virtually the same, but there are subtle differences. We don't mention the proxy protocol anymore. We don't need to, because there's no proxying happening. It's happening natively in the process. There's no backend reference either. We don't need to have a backend connecting the TLS terminator to Varnish, because it doesn't get terminated elsewhere anymore. It's all native. Now, don't worry, even if you take your existing Hitch configuration file and you drop it in here, we will ignore the parts that don't really matter. That makes it easy. And what you can basically do is copy your Hitch configuration and just link it with -a uppercase. So -a uppercase is the only thing you need to do. It will read that TLS configuration file, open up the ports, read in the certificates, and handle all the crypto bits. Now, please don't confuse it with minus lowercase a, because minus lowercase a is just for regular network port and listening in this case. So minus a will be used to open up port 80 for HTTP traffic, but minus uppercase a will be used for everything in regards to TLS. Now, you don't need to assign a minus a lowercase to 443, which is the HTTPS port. All of that is done in the configuration file. And the end result is quite spectacular. We can process about 150 gigabits per second on a single machine using in-core TLS, which is a very decent number and something we're really excited and really proud about. That was something that my colleague Fraser hinted towards as well. And based on benchmarks, we noticed that we were faster than competing products, even with using lower resource consumption. So although we're faster, we're consuming less, which was really exciting for us and really happy for us to go forward with that. But it required a little bit of changes in the VCL as well, and we needed to offer an extra module for TLS. There's no proxying happening anymore, so we can't determine whether or not SSL is used based on the incoming connection. We needed to do that locally. So we decided to just make a very similar module called TLS, and you can do TLS detection in a similar fashion. So that's that, and it works really well. But I do like to stress, and this may sound controversial, that Hitch is still an essential part of our reference architecture. Not everyone is using in-core TLS. It has specific use cases. And we would advise you to use in-core TLS if you need the speed. If you have the need for speed, well then, if you want to go beyond 100 gigabits per second per server, in-core TLS is what you need. Maybe also, from the sake of simplicity, if managing that extra terminator, the TLS terminator, is too much of a burden on you, well, then by all means go for native TLS. What I do want to stress, more for a conceptual point of view than a practical point of view, is that Hitch is very secure. Because we have a separate server running a different user, separate process space that does that one thing, the TLS part, there is an added layer of security. I'm not saying that there's security vulnerabilities lying around, but if that were hypothetically to happen, the only thing that would happen is that the TLS bit would be exposed, whereas your cache would still be very secure. Again, that is more from a hypothetical point of view, but it's still something we adhere to. And I can't talk about encryption without mentioning the fact that we have end-to-end encryption possibilities, all of which I explained in the last 15 minutes is in regards to client-side termination of TLS. We also have backend TLS. And that's the last thing I'm going to show you before I dive into my second presentation is your backend definition where Varnish connects to the origin server. Well, you can enable the SSL flag and the connectivity will be done over SSL. So that was part one. Time for part two. I already explained with this in-core TLS that this is a very new feature, but there's plenty more where that came from. And the very first thing I would like to talk about is also something that was hinted by Michael. So thank you for being the hype man here and building up the expectations. Memory governor is one of those features. And memory governor is a really exciting feature that was developed also by one of my colleagues in Oslo. His name is Martin. And when I heard the name, it was very deserving of an image like this. The memory governor. It seems like a vague term, but Mike already hinted that it helped the people at RTE, or it will help them to balance memory consumption and sizing. And it actually tackles the sizing problem quite a bit. How do you properly size your Varnish server? How much memory do you allocate? How big do you make your object cache? How much space do you leave for other bits and bobs that might require memory? That is a tricky thing in production and definitely at super high scale. What the memory governor does is automatic memory management. And that might sound vague to you, but allow me to explain it in a very practical and visual way. So I'm going to try to sketch the problem here. Imagine that you have a server that has 90 gigabytes of memory, and you want to leave some headroom just to be on the safe side, what every operational person would do. So we decide to only allocate 80 gigabytes for cached objects. But later on, you notice, out of experience, that there's a runtime cost associated with running Varnish. It's not just the objects in cache that consume memory, it's also running the threads storing the objects. There might be, and this is just per object kilobytes, both for object overhead and workspace client space. This can be kilobytes, but if you serve large volumes of data to a huge audience, oh, that will add up. And you might have 5 gigabytes of memory being consumed for object overhead, or 5 gigabytes for workspace client memory. Workspace client memory is what is consumed when opening up threads, when accepting requests, when opening up connections. But in order to leave the headroom intact, that 10 gigabytes, we need to downsize our cache. So where we used to have 80 gigabytes for cache storage, we only have 70. And then later on, we learned that there's also a thing called transient objects. These are objects that aren't necessarily stored in the regular object cache, but in a different piece of memory. These are short-lived objects, or hit-for-pass objects, as we call them, and they might consume 5 gigabytes as well at a reasonable scale. So far, so good. You made some compromises. You only have 65 gigabytes for caching, but you have a sense of stability. But that only applies for stable traffic patterns. If you have a huge spike, well, all of a sudden that 5 gigabytes can turn into 6 gigabytes of transient storage. The same might apply to the object overhead, and the workspace client memory could spike from 5 gigabytes to 8 gigabytes, and you're literally eating out of your headroom. All of a sudden you have less reserved memory for emergency situations or for other services. And maybe, just maybe, you might make that crucial VCL mistake by lowering the TTL for a bunch of objects, making sure that they're short-lived and no longer fit into regular cache, but go into transient. Your transient explodes from 5 gigabytes to 17 gigabytes, and instead of eating out a bit of your headroom, you just went completely out of memory, and Varnish is out. So these are scenarios you want to avoid at all costs. And yes, there's a fixed amount that you can set ahead of time, the size of the object cache. There's the variable amount that we need to tackle, that we need to cater for. And that is exactly what the memory governor does. So instead of just limiting the size of the cache, we limit the size of the entire Varnish process. And instead of having a variable, a fixed amount, everything is fixed. The total size of the cache is fixed. And that is part of a storage engine that we call the massive storage engine, or MSE. Now, MSE is something that we use quite commonly. It's an enterprise-only stevedore, as we call it. And the stevedore is not a person who necessarily works at the docks and is in shipping, but it's sort of code name, a word we use to define the different storage engines we have. And when you use Varnish out of the box, be it Varnish Cache or Varnish Enterprise, malloc will probably be used. It's just a memory stevedore, memory allocator. It has its limits at certain scale. That's one of the reasons why we developed massive storage engine. But the alternative, if you have lots and lots and lots of objects that you need to store in cache and you don't have enough memory, you might opt to use the file stevedore. Again, this came from the open source project and it serves a purpose. But problem number one is it's non-persistent. So if you restart Varnish, even though you stored it on disk, all will be lost. And it's also very prone to disk fragmentation. And that's something that will bite you later on, the bigger your cache becomes. So it's a bit of a trade-off that people had to live with throughout the years, but we decided for our clientele that we had to come up with a better solution. And the massive storage engine is such a thing. It combines a mixture of memory and disk storage, but without the typical compromises. And you'll see that in the next couple of minutes or seconds. A use case that you're trying to tackle, let's go for a video on demand platform. You have the very popular content, your top 10, top 100 series, and maybe in terms of total size, it's quite manageable and it might fit into memory, and that's your head content. And that will be lightning fast. People will consume it at very high scale. But then you have those typical parts of your catalog that aren't that popular, but that still need to be delivered with an acceptable quality of experience. It's what we call the long tail. And that's where the storage part will kick in. And this is what it will look like from a conceptual point of view. When a user accesses Varnish, most of it will come from memory. But when something is not in memory, in this case, that's 100 gigabytes of memory, we can fall back to the storage layer. The storage layer can act as a secondary origin. And in this case, we have 4 terabytes of storage divided into 4 separate stores. And each of those stores, or 2 of those stores in pairs, they're associated with books. A book is a database, a memory mapped database that will hold all the metadata and all the extra information and the journaling. Everything that makes it more reliable and everything that identifies objects in cache. Whereas the raw payload will be stored in these so-called stores. There's 4 of them, and these aren't just disks. They can be located on different disks, but these are pre-allocated large files, and that is part of the efficiency. Because the typical things for an operating system, and disk-based storage will slow you down, is let's say you have 1 million objects you want to store. Well, that might result in 1 million files on disk. That will result in lots of directory iteration. That will result in lots of file openings. You may run out of file descriptors. That will result in typical latencies that you don't want to have. What we do is we pre-allocate those files and we leave them open. So there's only 4 files, but because they're pre-allocated, you won't have a lot of fragmentation. And we've designed them in such a way that the content is streamed through and is lightning fast. We also apply a watermark for availability. So that means at any given point in time, for example, 20% of the cache should be available for new objects. And a thread will run through making sure that the necessary space is also always available by eliminating the least popular items from cache. So it's not your standard storage solution. It is actually something we use to guarantee persistence, disk-based storage, but without the typical latencies, as I mentioned before. So again, less overhead per object, smarter LRU, cache persistence, pre-allocated large files on disk, and very important, less disk fragmentation. Now this is a build-up. We're talking about new features in Varnish. MSE is hardly new, but it serves a purpose in this presentation. The way you configure MSE is again with a separate configuration file called mse.conf. You define this data structure, the environment, you give your environment an ID, and to start off with a memcache size. In this case, that's 100 gigabytes. If you want persistence and if you want to take advantage of storage, well, then you can define books. Books is also part of the data structure, and it has a location where the book is stored. This is a file that is mapped into memory and preset in terms of size. And one book can have multiple stores. There could be multiple books as well. And these stores will probably be hosted on separate disks. And in this case, disk 1 will have a terabyte store1.dat file, and store 2 will be on disk 2, will also be a terabyte in size. So that's how that works. The way you actually leverage it is by initializing these paths. You don't need to create these files yourself. You run an MKFS, so make file system binary that we ship, a custom one. Everything is set up on disk, and it's just a matter of linking this to Varnish by the -s parameter. -s stands for stevedore, so that's where you define what kind of storage engine you're using and where the configuration or the size is. So you may ask yourself, how is this related to the memory governor? Isn't this supposed to be a pitch about memory governor instead of just MSE? Well, you needed to know about the power of MSE, but also the configuration format to appreciate how memory governor works and how you can enable it. And you can enable it by just switching your memcache size in your MSE configuration file from the set amount you want to use to auto. So by setting auto, all of a sudden everything starts working automatically and the size of your cache is automatically increased or decreased depending on the traffic patterns. But the next question you might ask is, well, if everything is automatic, how do I manage the total size? How do I set the upper limit? And that is done through a runtime parameter. And there's different ways of configuring it. The runtime parameter is named memory target. And you could have it bootstrapped into your Varnish startup via a -p parameter and then just mention memory target and either choose a percentage or an absolute value. So you could see in the first example that we opted for 80%. So 80% of our total memory will be allocated to Varnish, the Varnish D process. And the remainder, 20% that is left, is up to the operating system to consume. You can also say, I don't want a percentage. I know quite well how much memory I want to consume, and you could set that. Now, the first 2 examples already have an mse.conf file, primarily because of persistence reasons. But if you don't have a persistence layer and you only want to use memory governor with memory, you can omit this path to varlib mse.conf. And you can just mention -s mse and either define your 50 gigabyte or your 80%. But you can go one step further. You can go all the way down, the final example, where you just mention Varnish D runtime process and do -s mse. And that will automatically enable the memory governor and will automatically use the machine default of 80%. And that's how that works. Next question you might ask yourself is, how do we measure the size of the object store? We set the size of the total process, but how do we know what the size of the object store is? And luckily, we have some counters for that. Here are 3 counters that are relevant to this. So the first one, G bytes, is the amount of bytes that are in use. That's the space that is in use. And if you want to know how much space is left, you can use g_space. And if you want to know the total memory consumption of the Varnish process, there's even a separate counter called gmemRSS. So that's that. That is everything in regards to the memory governor and everything in regards to MSE. The next thing I want to show you is a bit different. So the first part of this presentation, so we talked about SSL and TLS. That was a big one. Then we talked about memory consumption and cache persistence, which is also a big element of Varnish Enterprise. The next thing I'm going to talk about is a JWT vmod that fits into, I wouldn't call it a niche, but a specific industry where Varnish can serve as an authentication gateway or as an edge decision-making gateway, which is very important. JWT stands for JSON Web Tokens, and vmod JWT is a recently released module that allows Varnish to inspect, verify, and modify these JSON Web Tokens. You may ask yourself what that looks like. Well, ladies and gentlemen, this is a JSON Web Token. It looks a bit like gibberish if it weren't for the color coding, and I'll get back to the color coding and how that works. A JSON Web Token is a secure token that is issued by a web server, primarily a web server that serves APIs. It's not commonly used in web browsers. And then it's up to the client, which will probably be an API client, to issue that token upon every request to authenticate itself. So username and password were already provided, and now we have this session. The interesting bit about this is that this token is just not a lame basic token that the server needs to validate and access databases for. No, it's self-explanatory. It contains lots of client state, and even the client has a view on what this token can do. You'll see that in a minute. Now, the reason why I'm saying that browsers don't support it, browsers do support authorization headers, but they usually use basic authentication, a typical pop-up. This is bearer authentication. Now, this JSON Web Token, as you can see by the color coding, consists of 3 distinct parts, each of them separated by this black dot. So you have a header in red, the payload in pink, and then the cryptographic signature in blue. Each of these parts is base64 encoded JSON, and the secret is actually a cryptographically secure signature using HMAC. So let's decode those parts. So if you would decode that first part, that would be the header, and that would contain the algorithm and the type. In this case, this is a JSON Web Token. Could be a JSON Web Signature as well, or JSON Web Key, but in this case, it's a JSON Web Token, and it is signed with an HS256, which is HMAC with a SHA-256 hash. You can also see that the names of the fields in this JSON objects are quite short. ALG instead of algorithm, TYP instead of type. And the reason is that the shorter we make it, the more compact we make it, the less data we have to send over the wire each and every time. So be careful with the size of this. What you can also see is in the actual payload, there's some conventional claims there, such as sub, IAT, EXP. These are again compact, and you can, if you go to jwt.io, it has lots of information on that. So this is all the information that the web server issues and that the client can actually view. So this is not secret information. That's very important. These are public claims that the user can see. So please don't store information that the user has no permission to see in there. What you can see is a sub, which is the subject. That's probably user ID. You can have a name, in this case, John Doe. And IAT is issued at, that's a Unix timestamp telling both user and server when it was issued and when it expires. So as a user, you also already have a pretty decent view on who you are and also how long this token is valid for. And then you could say, well, is that actually a secure way of doing this? Because let's say there's a flag called admin that is set to false for you. Well, if you set it to true, all of a sudden you do privilege escalation. Or if your token expires at a certain moment, you can change the expiry date and actually trick yourself or trick the server into giving you access. Well, that is secured, and that's where the magic is by this blue part, by the signature. The signatures are composed of the header and the payload, and it is encrypted with a secret key. So if you don't have the secret key, you can't create the secret. So that means if someone is clever enough, a client is clever enough to change the web token and maybe do privilege escalation or extend the expiration date, the signature won't be good anymore. So when the signature is matched again, it won't match anymore, and we know that something is wrong and will deny access. By default, Varnish doesn't serve items from cache that have an authorization header, nor if there's a cookie. Because the idea behind these types of information is that it's for your eyes only. If it's for your eyes only, we don't want to serve it from cache and serve it to everyone. But we do have this initiative in Varnish, and it has been there for years, and we're focusing on it year after year, is turning Varnish not just into a stupid take it or leave it cache, but into an edge decision-making machine, an HTTP logic box, which makes uncacheable information cacheable all of a sudden. Because if we do all the decision-making regarding the authentication of the JWT token on the edge, we can cache something that was previously not cacheable, and we take away that burden that lied on the web server, the origin server, and change that to Varnish. And the way we're going to do that is we're going to write some VCL and use this vmod JWT to do it. And this module was developed by my colleague Andrew in New York, and he created both a reading and a writing component. In this case, we're going to set up the reader. Now, I'm going to guide you to this because it contains a little bit of, I would say, hidden information, but you need to know what is happening here. So that sub VCL init will initialize the module. It will be imported first, but it will be initialized. The reader will be initialized firsthand. And then sub VCL receive is a hook, a subroutine, where we can extend the behavior when a request is received. So in this case, we're looking at the authorization header that comes in as a request header. And we know, a couple of slides earlier, you saw that it was a bearer authentication token and then the token itself. And we know that the token consists of 3 distinct parts separated by dots. So we're trying to match this from a purely static point of view. We're not introspecting the JWT, we're looking at the format. And if the format does not match what we expect, if it doesn't match that regular expression, then we return synthetically. We don't go to the backend, we immediately quit, give it a 403 and said, you are not authorized because the format doesn't match. If the format does match, we're going to extract the token and substitute this into a JWT request header. And then we are going to introspect whatever that token was, we're going to inject into the JWT reader. And if the parsing fails, it means we don't have a JWT. If the parsing succeeds, but it is not a JWT based on its header information, then we're going to say, sorry, the token is not valid, it's not a JWT, and we're going to output what it was, so as a user, you can see what you sent. But later on, we need to make sure it's cryptographically secure, it's not tampered with. So we set the key, it could be a secret key located in etc varnish jwt.secret, and we'll match it. We'll use the HMAC signature, HS256, and if those two match, we know something, everything matched. If it returns false, it was tampered with, and we return with an unverified JWT error. If we jump through all those hoops, it means we have valid authentication, the user is authenticated, and items can be served from cache. That's pretty convenient. Now, in this case, we're not a JWT issuer, we're a JWT verifier. We can also issue these tokens, but it just goes to show how flexible this module is and how it can help API developers to offload certain logic from the origin to the edge. Another one in that wheelhouse of edge decision making is another brand new module called vmod SQLite tree. Now, SQLite tree is a database. It's a very lightweight, simple file-based relational database. And you can use that to query on the fly on the edge. So I have a quick little example for you. In this case, what we're going to do before we dive into the VCL, the premise of this example is that some service might have issued a cookie called ID where your user ID is in. And when you connect, we will fetch your user ID from the database and try to get your name and then display that name. We're going to do that in a synthetic way. We're not going to fetch it from the backend. We're going to compose it ourselves, and we're going to leverage our synthetic backend module for that as well. So in the initial stages, we're going to open the database, which is located in sqlite.db, that's the file, and we're going to make sure that we have the right row and column separators, respectively pipe and semicolon. And then you can populate that. Now, you'll probably populate that, or you have it pre-populated. Database will probably contain the tables and all the users you need. But for the sake of this example, I'm going to create a table users with a name field, and then insert Linda, John, Charles, and Mary in there. And in the end, when all of it is done, we'll close the database. When we receive a request, and if we see that there's a cookie called ID, and it matches a numeric value, we're going to extract that value and store it into user ID and look it up in cache. When it's not stored in cache, we're going to fetch it. And normally you should connect to a backend. But if you go all the way to the 5th line of this example, you'll see backend default none. So we didn't even take the effort of setting up a backend because we're going to handle it all synthetically. What we'll do ahead of time is try to get the username for that user ID. And that's where we call the SQLite tree exec function. We do a typical SQL statement, select the name from the users table where the row ID, which is a sort of implicit primary key, where that matches the user ID. But just to be on the safe side and not have any SQL injection, we escape the value to make sure that this can't be tampered with. If the username turns out to be empty, if we didn't find it, well, then we have guest access. And otherwise, we have the username. And in the end, we'll feed it back to Varnish as if it were an actual connection to a backend, but it comes from a string. And then we say, welcome. That could be Linda, John, Charles, or Mary. Yeah, that's, again, a very powerful one. There's so many use cases for it, and you can actually join them in with vmod JWT and sort of your secret key in there or populate claims from it. It is just one of these features that was requested by clients. It's very lightweight, and it works well from our edge decision-making point of view. Now, the last one before we end here is also a very recent one, vmod stale. So what did we already cover? We already covered TLS. We did the memory governor, and I explained how MSC works. So that's from a memory management and persistence point of view. I talked about edge decision-making. Here we'll be talking about how to deal with failure in a very comfortable and efficient way. vmod stale is actually our implementation of stale if error. And stale if error is a concept where, as a proxy, as a caching proxy, you will serve stale content to the user if we detect that the backend is down. If our web server, our origin web server is down, we're not going to feed the error because it's not the way to go. You're not going to serve that ugly 500 internal server error. The thing you had in cache that was valid before the things went bad, you want to serve that while you wait for it to come back. Now, in order to achieve that in Varnish, we need to know when something is considered stale. So the full object lifetime consists of the original TTL, the time to live, that could be issued in VCL. It could be done through a cache control header. That is your basis, your foundation. If that has expired, you're dealing with a stale object. But what you can do is you can add some grace, as we call it. This is called stale while revalidate. And internally, it's called grace mode. And this is a number of seconds, minutes, or hours, or even days you can add on to that TTL, where it still be served stale while you're fetching the latest copy. The consequence is that you might be serving outdated data, outdated objects for a number of seconds, minutes, or hours. You also have keep, which is when you're out of grace, but you still want to keep the object around, not necessarily to serve it, but to keep it around, you have keep. So imagine this scenario. A host of clients connects, maybe hundreds or thousands of clients connect at the same time. The object is stale and out of grace, so you can't serve it directly from grace, but it's still around. There's still some keep. Because it is stale, it needs to be revalidated, or it needs to be fetched from the backend. But the backend serves 500 errors. The backend is not really responsive. It doesn't respond with the content we were expecting. So what will be happening is 500 error codes won't be stored in cache. So whatever gets returned from the web server with the error will not end up in cache. So it will be served to that one user. And then the other user will have to do the same thing and the same thing. And all these users, while this is happening sequentially, will end up on the waiting list. And this can have a major impact. If you have thousands of users waitlisted, it can have a serious impact on your performance. The reason why we invented vmod stale is to deal with that in an elegant way. So what we do is if we notice that we have a 500 error or something within that range, and something is still stale, we can revive the object and serve it from cache. But without doing it in a graceful way, without using grace, without using stale while revalidate. And I know it's a complicated concept, but I'll show you some code and hopefully that clarifies things. So we import this vmod stale, and we built this custom subroutine, stale if error, that we trigger when the backend responds or when the backend returns an error. You can see that in these two other subs, we call it call stale if error, and you see that twice. What it actually does is it tries to detect if the backend response, whatever the backend responded with, if the HTTP status code is equal or greater than 500. If you're in the 500 range, there is a server issue happening and you're in big trouble. But what we also do is we see if a stale object still exists. And if it does exist, we're going to try to revive it. We're going to try to give it 20 minutes more TTL and an hour more grace. Now, this is trying. What we'll do is we'll respect the original time of death and the original TTL. This is just the minimum that we want. If it turns out that the original TTL was 5 minutes, then it will be alive for another 5 minutes. All the excess, everything on top of the grace and the TTL will be stored in keep. And then we deliver it directly to all the users in the waiting list, and we abandon the regular dispatch loop. And in order to make sure that it is stale, that it is confirmed as a stale object, ahead of time, we will set the keep value to, in this case, it's 7 days. So if all works well, for the next 7 days, your web server can be down and content will still be served to your users without them knowing that anything is wrong. It's a little bit more complicated, a bit more abstract, but it's, again, something that was requested by our users and that will be very popular going forward. And that's the way how parts of our roadmap get built up. A lot of it comes from real world experiences from us, but also from our clientele. So that was that. I'd like to thank you for being part of this for the last 43 minutes. And I'm going to hand it off back to Fraser. Hope you enjoyed it, and don't hesitate to get in touch if you have any questions.
Thanks, Tess. I'll just reshare my screen here. Just to conclude in the last 10 minutes of the time that we have available, we have a couple of questions, both for Michael and for you, Tess. But I'll start, Michael, with a couple of questions that we've had for you. The first one being, what prevented you from doing or building the CDN in Varnish Cache?
Good. It's been a while since we made that decision. The first one is support. Like, this is the business critical application for us, and we do need the backing of a team of engineers when we deal with issues. But also, there's quite a few features that we've used over the years that are only available in Varnish Enterprise. So we use the Varnish Administration Console, VAC, to manage and deploy pools of servers and deploy configurations. Things like the massive storage engine, like we did previously use file-based backends, but they really don't scale well. They don't perform well after periods of time. You end up with that fragmentation of disk, whereas MSE gives you a much greater ability to use disk-based storage, which is the only real option when you've got a large on-demand catalog of video to deliver. I'm just trying to think if there's other features that we've used over the years. Yeah, the primary one I would say at this point in time is the massive storage engine and the Varnish broadcaster. They significantly reduce the requirement for hardware to deal with traffic.
Yeah. No, perfect. Thanks for that. Hopefully that answered the question. The second one that I have here for you, I'm not sure if I do quite want to ask this, but someone has asked what the challenges have been of you, I assume, building this platform yourselves.
The biggest problem we have isn't on the technical side at all, really. It's on the manpower side. Like, we need a team of people who are able to deal with these products, and they're not like WordPress that every dog in the street is running a WordPress site. To build up an expertise in your team is relatively tricky, especially in a relatively small country. But from a technical perspective, there isn't really any blocker. The financial decision is relatively simple for us, and operationally it's relatively simple, but having a team of skilled engineers, that's the trickiest element for us.
No, that makes sense. And if I may ask just a question of my own on that point, how big is the team that you're currently implementing, or that you currently have to implement this solution, I should say? The
team that look after our media delivery also look after all of our networks, all of our corporate networks and our broadcast media networks, and we're 4 people in total. We also do all of the security for our environment. but it's 4 people. There's other teams that look after, the origin servers and so on. But there's only 4 people who are capable of dealing with Varnish at the moment.
Okay. No, that's clear. So it doesn't take a massive team, just some intelligent people to get it going.
Yeah, it's the same with all of these environments. A couple of skill guys can do an awful lot.
Okay. No, perfect. And one last one that we have for you. I think you alluded to this in your answer to the first question, but what tools do you use for monitoring and management of the platform?
I prefer you ask me that question in a month. We currently use a range of just off-the-shelf tools, things like standard SNMP monitoring tools, PRTG. We're actively looking for something good in that space. Like, we're using a lot of home-built things. You'll find some on GitHub, things like Varnish, which one of my former colleagues, John Moylan, wrote for monitoring the environment. And we're looking at some of the commercial off-the-shelf tools. And we're also looking at some new features coming down the tracks from Varnish. One of my colleagues is actually working with you on seeing if that's suitable for our environment. So that'll be a Prometheus-based monitoring setup. But like the standard commodity SNMP tools are pretty much what we're using.
Okay. No, perfect. Well, thank you for that, Michael. I think that's all the questions that we had for you. It seems as though, Tace, there are a couple of questions for you as well. The first one being whether TLS, I assume that you presented today, adds any latency.
Well, it always adds a little bit of latency because like the handshaking is a bit more CPU intensive. But what we try to do is make it efficient as possible to, and I can't give you the numbers, of course, I should ask my colleague who developed it, but we try to keep it as low as possible. And I think the numbers themselves, originally 100 gigabits per second per server, going up to 150, proves that we can process quite a bit with that. So yes, there's always is overhead, but it's our responsibility to minimize it and use the most efficient technology out there to get it done.
Okay. No, perfect. And I think the second one is in a similar vein, perhaps more a practical question that we've had, is what version of Varnish is TLS supported from?
I think it is 6.0, it's a 606R3, I guess. But if you get Varnish Enterprise now with 606R5, it will already be there. But I guess it's 606R3. I should check it for you, but I can, if you want that to happen now, I could check it directly for you.
Yeah, no problem. We can follow up with the
next
person who's asked the question after the call. But yeah, I think in summary, it's essentially the latest version of Varnish that it's available on. Okay, well, it seems as though those are all the questions that we had. So I think now, in the last couple of minutes, I'd just like to conclude. And firstly, in particular, thank you, Michael, for joining and adding some Irish charm to the presentation this morning. It was really interesting to hear from my perspective and hopefully from the perspective of people who have joined the webinar today, how and why you've made the decisions that you have to build the platform on Varnish, and great to see that it's been a success so far. But also, Tace, of course, thanks for joining and for presenting some of the interesting things that we're doing.
And I do have an answer to your question. The in-core TLS was released in 606R2, and that happened on March 18th of this year.
Okay, thanks, Tace. But I would just like to say also, if there are any customers or anyone on the call who is interested in exploring some of the features that Tace went into the detail of there, then please, of course, reach out to myself directly or to support, and we'll be happy to discuss those in more detail. But otherwise, I look forward to following up with everyone personally, and if for any reason you would like to get in touch with me before that, my details are on the screen here. and I look forward to hearing from anyone who would like to have a further conversation about some of the things that we've spoken about today. But aside from that, again, thank you very much for joining, and thanks in particular to Michael for taking some time this morning to present what you've been doing with Varnish. I hope everyone has a great day, and hopefully we'll be back to some form of normality soon, and the next UK event we can do in person. So thanks again.